Hi guys, this is Mr. Hirschman, and I'm going to show you how to solve a system of equations by substitution. To solve the system by substitution, we're going to first solve one of the equations for y. We'll then substitute the answer into the other equation and solve for x. I'm going to do those first two steps right now. I know that y in the second equation is equal to 1 plus 2x. Now I'll substitute that value into y in the first equation. Substituting for y in the first equation gives 2x plus 5 times 1 plus 2x equals 65. Now I can solve this equation for x to have an actual value of x. I collected like terms in the second step, and I found 12x plus 5 equal to 65. Solving from there, x is equal to 5. I'm now ready to start to substitute the value of x back in to one of the original equations and solve for y. Remember, I can substitute x into either of the first two equations to find the value of y. Doing it for one equation would give me an answer. So substituting x into both equations will allow me to check my answer and ensure that I've solved the system correctly. Substituting 5 for x in the first equation gave me y equals 11. I checked my answer by substituting x equals 5 into the second equation, and again I found y equals 11. So I know I've solved the system correctly, and I'll write my answer as an ordered pair, 5, 11. If we graphed this system of equations, the two lines would intersect at the point 5, 11. I'll show you that. The equation 2x plus 5y equals 65 looks like that, and negative 2x plus y equals 1 looks like this. Looking at the point where they intersect, we can see that it's 1, 2, 3, 4, 5 over and 11 up. Point A has the coordinates 5, 11, just like we found through substitution. Now we'll do another example. To solve the system by substitution will be easy because the first variable has already been solved for. We know that y is already equal to 2x plus 1. Now we can substitute into y in the first equation. Again, this gives an equation that only has x's in it, so we can distribute and solve for x. Again, we'll substitute x equals 3 into both of the equations to solve for y and to check our answer. The first equation solves to y equals 7. So does the second, so we know our answer is correct. Write the answer as an ordered pair, and I'll show you a graph of the equations so that you can see that we correctly solved them. Negative 2x plus 5y equals 29 looks like this on the graph, and y equals 2x plus 1 looks like this. You can see that the point of intersection is 3, 7, where point A is. Remember that the solution represents the point where the lines cross. Substitution can help us solve a word problem, like this one involving two trains. Notice that there's a train that leaves Portland towards Seattle, and one that leaves Seattle towards Portland. Imagine what the situation would look like by drawing a number line. Note the velocities of the trains and the total distance they have to cover. Doing a little estimation, I can tell that the trains will cross somewhere between 1 and 2 hours into their journey, because at 1 hour they would be 70 miles and 60 miles away from each city, which would only leave 70 plus 60 is 130, which would only leave 56 miles between the two trains. At the second hour, the train from Seattle would be 140 miles down the track, and the train from Portland would be 120 miles down the track, which means both of the trains would have crossed because 140 plus 120 is more than 186. To solve this problem, we'll define two variables. Y will be the distance of the trains from Portland, and x will be the number of hours they've been traveling. Since the first train starts in Portland, or since I'll say the train from Portland is the first train and starts from Portland, its y-intercept would be 0 because it's starting in Portland. Therefore, its distance from Portland is given by 60 times the number of miles that it's traveled. The train from Seattle, on the other hand, starts 186 miles away from Portland and gets less far from Portland as time goes on because it's constantly moving towards Portland. And its distance to Portland is shrinking at a rate of 70 miles for each hour. Because the two equations in this system are already solved for y, we can substitute one of the values into the other equation. This will allow us to solve for x, thus giving us the exact time in hours when the trains cross. We'll now use this value to solve for y and check our answer. At this step, I would cross-reduce. Solving for y, now I know that the trains cross 1 and 28/65 of an hour after leaving the station, and they would cross 85 and 11/13 miles away from Portland. I'll substitute into the other equation to check my answer. Make sure you multiply 70 times the fraction before you subtract. From solving for y in the second equation, I know my answer was correct the first time. Because this is a word problem, I'd write my answer in a complete sentence. My sentence would read, the trains will cross after 1 and 28/65 of hours, and they will be 85 and 11/13 miles away from Portland. A graph of the two equations would look like this. You can use your calculator to verify that our answers work out to be the coordinates where point A is, even though A has been rounded to 2 decimal places. So that is how you solve a system of equations by substitution, and one of the things that you can do with it. I hope this helps when you're working on your homework this week in class.